All right, friends, in order to find the missing length for a side of a rectangle or square, we're going to use our formula and manipulate it. So our formula is area equals base times height. In order to solve this, we're going to put in our numbers that we have. So for area, we have 306. And we have a base of 17, and our height is unknown. What we want to do in this situation is we want to isolate the 17, and in order to do that, we have to do the inverse operation. Inverse operation meaning the opposite operation of multiplication. The opposite of multiplication is division. So when I divide 17 by 17, I am left with h, because 17 divided by 17 is the same thing as having 1. 1 times a number gives you the same thing, so I have h here. And what I do to one side, I also do to the other, so I have 306 divided by 17. So I'm going to set that up as a long division problem. Top goes in, the bottom number goes out. 17 goes into 30 one time. Subtract 17. Need to borrow. 10 minus 7 is 3. 2 minus 1 is 1. Bring down the 6. I'm going to try how many times 17 can go into 136. I'm going to try 8 because I know that 7 times 8 is 56 in hopes that this gives me the right answer. 7 times 8 is 56. 8 times 1 is 8. Plus 5 is 13, and that's perfectly the answer. So my answer for this problem should be h equals 18 kilometers. And that's how we would solve a problem when we're looking for the missing side length when given a square or rectangle. Another question that we had trouble with is just finding the area for a trapezoid. Now, the formula for an area of a trapezoid is A equals base 1 plus base 2 times height divided by 2. So base 1 is, I always treat base 1 as the top number at the top, so I'm not, and then base 2 is the one at the bottom. So I'm going to have 6 plus 10 times the height, which is 17, all over 2. So remember, according to order operations, we have to do what's inside the parentheses first. So I'm going to do 6 plus 10. So 6 plus 10 is 16 times 17 divided by 2. Now, I'm going to show my work over here for 16 times 17 to make sure that I am not just doing mental math. 6 times 7 is 42. 7 times 1 is 7, plus 4. That would give me 11. Once I have that, I need to put a placeholder. 1 times 6 is 6. 1 times 1 is 1. 2, 7, 2. 272 over 2. Now on this problem, what I'm going to do is I'm going to divide 272 divided by 2. 2 goes into 2. 2 goes into 2 one time. Subtract 2. Bring down the 7. 2 goes into 7 3 times. 2 times 3 is 6. Left with 1. Bring down the 2. 2 into 12 is 6. So my answer for this problem is area equals 136 centimeters squared. All right. And then here, this is where we also struggled mathematically. So remember on our notes we did on the grid. So in order to find the area for shapes like this, what we're going to do is we're going to decompose the shapes into figures that we know. So we can break shapes into rectangles. So for this rectangle here, this rectangle has 1, 2, 3, 4, 5, 6. 6 times 2. And 6 times 2 gives me an area of 12. This rectangle here has a base of 3 and a height of 4. So it's going to also be 12. And if I combine those, right, that's going to be 12 plus 12, which is going to give me 24 square units. Now remember, the units are super important, so they need to be attached. Anytime we're finding area, you should always put it in square units, especially if you're not given the unit. On this type of problem, we need to find the area of the shaded region, so we cannot include the area that is technically not shaded. So for this problem, what we're going to do is, we can decompose the shape, or what we can do is we can go ahead and just find the base and the height of this, and then subtract the base and height of the smaller square. So the base of this is 1, 2, 3, 4, 5, 6. The height of this is 1, 2, 3, 4, 5, 6. And we're going to multiply that. So 6 times 6 is 36. And then the area here is going to be 3 times 3, which is going to be 9. Take away 9, and we're left with 27. 27 square units. Okay. On the following problem, this problem is a little bit more tricky, only because we're looking at triangles. Now what we need to remember about triangles is that two triangles put together make a square or rectangle, depending on if it's perfect or not. So in this situation, what we can do is we can actually move these physically over if we wanted to. But the thing about that is you have to be able to manipulate it. So I know that this has a base of 2, and this has a height of 4. 1, 2, 3, 4. Okay? If I know these two things, then I know basically that the formula for a triangle is area equals base times height divided by 2. So to plug in those numbers, 4 times 2 divided by 2. So I have 8 divided by 2, which is 4. So I know the area is 4 here. If the area is 4 here, all these are the same. So the area for this is going to be 4, this is going to be 4, and this is going to be 4, because this has a base of 2 and again a height of 4. This has a base of 2 and a height of 4. This has a base of 2 and a height of 4. So if I add all that area up, that's 4 times 4, which is 16 square units. Okay, now this last problem here, this problem is similar to this in that the shaded region, the area inside this is now shaded. And so we have to kind of use problem C to understand problem D to some degree. So what I'm going to do is I'm going to actually draw an extended square here to help me find the area of this this square that's on a tilt to make sure that I get it right. So now this problem looks exactly like C in that I extended it out. So I'm going to find the area of the perfect square, which that means that this is 6. This is also going to be 1, 2, 3, 4, 5, 6. 6 times 6 again is 36. And now I remember from over here that the area of these triangles were all 4. So since I added those triangles back in, I'm going to subtract the area I found from problem C, and that's going to leave me with 20 square units. All right, and then for the last page, or for the second part of that problem, we have problems that look somewhat like this, in that we had to understand how to solve the problem. So when I put two triangles together, remember that at one triangle, to find the area, I have to do area equals base times height divided by 2. So if I did 5 times 3 divided by 2, I would get 15 over 2, which 15 over 2 simplified is 7 1/2. Now, if I want to find the area of both of these triangles, I have to double this number because two triangles put together make a rectangle and a square. So 7 1/2 plus 7 1/2 is the same thing as having 15. right? Because originally, if I put two of them together, it makes a square or rectangle. So two triangles together will always give me that base times height, which is just 15. But we have to understand that basically one triangle is half of a rectangle or half of a square. And problem B, this problem is just like the problem that we did earlier in that it's 2 units again and 4 units. Remember, we're trying to find the area for a triangle. To find the area of a triangle, it's A equals base times height divided by 2. All right, so I'm going to plug in 4 times 2 divided by 2. And I'm going to get 8 over 2, which is the same thing as saying area equals 4 centimeters squared times 4. So I'm going to get 16 centimeters squared. And this should be, again, forgot the units over here, 15 centimeters squared. So this one is just like the problem that we just did, but now it's with numbers instead of being on a grid. For problems that look like this, we're going to have to find the area of what's shaded first. So to find the area of the square, it is 5 times 5, which is side times side, which is 25 centimeters squared. And then I have to find the area of this space because it's technically not shaded. So in this situation, I don't add it, I subtract it. So I'm going to take 2 times 2, which gives me 4 centimeters squared, and I'm left with 21 centimeters squared. So that is how we solve these problems. If you have any questions, feel free to email me, and I will do the best I can to help you.